Alright, today we're covering AWS SQS, Simple Queue Service. Here's what we're going to cover. What SQS is and why you need it, how message queues actually work, and when you'd use SQS in a real app. So SQS is a message queue. Think of it like the order system at a restaurant. You place your order, they write it down, and it goes into a queue. The kitchen then grabs the order one at a time and then processes them. And if they're busy, orders just wait in line. Nothing gets lost, so. That's exactly what SQS does for your apps. Let's say someone uploads a video to your app. You don't want to process that video right away because it takes like 5 minutes and the user's just sitting there waiting. Instead, you put a message in SQS like, hey, process this video. And then a worker service grabs that message when it's ready and handles it in the background. The user gets an instant response and the work gets done when there's capacity. Alright, here's how it works. Step 1. Your app sends a message to SQS. Could be process this image, send the email, generate the report, or whatever. The message sits in the queue. It just waits there until something's ready to handle it. Step 2. The message sits in the queue. It just waits there until someone's ready to handle it. It could be instant or it could be a few seconds. Step 3. A worker pulls the message and processes it. It could be a Lambda function, an EC2 instance, or whatever you got set up to handle tasks. Step 4. The worker deletes the message when done. Once it's processed, the message gets deleted from the queue. So if it fails, the message goes back in the queue to try again. So your app never gets overloaded. Tasks just wait in line and get processed when there's capacity. This makes it super clean. Real world example. So let's say you're building an app where users could upload photos. Without SQS, the user uploads the photo, your server immediately tries to resize it, compress it, generate thumbnails. If 100 people upload at once, your server is screwed. So with SQS, a user uploads a photo, you send a message to SQS saying, hey, process this photo. And then the user gets instant confirmation. Then the services grab those messages one by one and process them in the background. So this is way better. So your app stays responsive, nothing crashes, and all the work still gets done. Alright, let me show you what this looks like. So creating a queue is super simple. So you give it a name, and then you pick the type. The standard queue is fast, but messages might arrive out of order or duplicate. The FIFO queue is guaranteed order, no duplicates, but it is slightly slower. So most of the time you just go with standard unless you really need strict order. Everything else you can leave default, the visibility, timeout, message retention, all that. So then you click create and you're done. Then your app just sends messages to this queue and the worker pulls from it. It's super straightforward. You're basically just making a waiting list for tasks. So why do you need it? Why would you actually use this? Decoupling. Your app and your background workers don't need to talk directly. They just use a queue as a middleman. Handling spikes. If you got a sudden surge of tasks, they just queue up instead of crashing your system. And reliability. Messages don't get lost. If a worker fails, the message goes back in the queue and gets retried. It's basically a buffering between your app and your background processing, so super useful. So yeah, that's SQS. It's a message queue for handling background tasks without overloading your servers. User does something, you throw a message in the queue, the worker grabs it when they're ready, and the task gets done. Your app is able to stay fast and nothing crashes. So it's a super simple concept, but crazy useful once you start building real apps. So again, if this helped you, let me know, and I'll see you in the next one.